Welcome to the fourth part of the circular functions revision. State the sequence of transformations which transform the graph of y equals tan x to the graph of y equals negative 2 tan x over 3. Now, a quick look at what the tan of x graph will look like. It will go something like this, where we have an asymptote that comes through here, and then down like so. So we get one full repetition, then we get another asymptote down here, and we get another one. So that's 2 pi, but we get one full repetition within pi. We have the asymptote occurring at pi on 2 and at 3 pi on 2. And then for another coordinate value here, if we have pi on 4, then that's going to correlate to a y value of 1. And that will, at 3 pi on 4 in here, that will correspond to negative 1. So in this case here, we have one period occurs in pi. So if we had a function of y equals tan nx, the period can be determined as equal to pi over n. Now, in the case of the question that we have here, our n value is actually equal to 1/3. So for our case, we're going to have pi divided by 1/3, which is flip the third and turn it into a times, which will give us 3 pi. So what that's actually going to do is stretch the graph out in the horizontal direction, in the x-axis. The second thing that's going to happen, well, not actually the second, the first thing that will happen, but we'll get the order of these in a second. The other thing that's going to happen is that this 2 is going to stretch all of these y values up. They're going to double them all. And this negative is going to flip it or reflect it. So it's going to be flipped upside down or reflected in the x-axis. The 2 is going to double all of the y values that we have, and this 1/3 is actually going to stretch it out away from the y-axis. So the order that these translations will happen is that first we look at our dilation from the x-axis, so the stretching away from the x-axis or in the direction of y. So we're going to have a dilation of factor 2 from the x-axis, factor 2, writing the word 2, need to sleep, factor 2 from the x-axis, or that could have been in the direction of y. There's another way of writing it. So that deals with this 2 here first. Then we're going to deal with this period thing. It's a dilation. It's a stretch. It's a dilation. Now, what this is doing is it is stretching it out further. So where we said here that the period becomes 3 pi instead of 1 pi, so one cycle normally would have occurred there, it's going to mean that our graph is going to look something like this and come way up over here like so, and that'll finish there at 3 pi. So it's actually been stretched away from the y-axis, so it's a dilation factor of 3 from the y-axis, And then finally we're going to deal with this negative sine at the front, and then a reflection in the x-axis. So that would be the sequence of transformations, transforming y equals tan x to the graph of, I've scribbled all over it now, y equals negative 2 tan x over 3. So we deal with our amplitude one first at the front here, then we look for any dilations that might be occurring in the x direction or away from the y-axis, and then we'll deal with any reflections in the x-axis last. Okay, let's move on to the next question. This is a similar question in that we're looking for a sequence of transformations, transforming the graph of y equals cos x to the graph of y equals 3 take away 3 cos of 2x. So I'll again draw a little graph of what cos of x would look like. Where we have one period in 2 pi. That'll happen at pi on 2, 3 pi on 2, and goes up to a maximum value of 1, minimum value of negative 1. Okay, so what's going to happen? The different components of it. This bit here is going to shift it up. This bit here is going to stretch it up and down. And this one is going to dilate it in the y direction. And this thing in here, the negative, is going to reflect it in the x-axis. So the first thing that we're going to deal with is our amplitude. So the 3 here is going to bring it up to a positive of 3. So that would stretch everything up that way. So a graph of 3 cos x would go something like that. So I'll actually write that there. So the first thing we're going to have is a dilation factor. It's going away from the x-axis, so it's a dilation factor of 3 from the x-axis. Or in the direction of y you could have had there. Now, next thing we'll do is we'll look at what the period is going to be. So the period for this graph equals 2 pi over n. In our case, n is equal to 2. So it's equal to 2 pi over 2, which equals pi. So that tells us that the whole graph is actually going to have one full rotation within pi. So the graph would be something like that as our second part of our transformation. So that's actually been squashed up a little bit, dilated towards the y-axis, squished up towards the y-axis, or a factor of a half away from the y-axis. So when it gets closer, it's only going to be half the original size, so we'll call it a dilation because it's a squishing, it's a dilation factor. It only goes half the distance away from the y-axis, so it's a dilation factor of a half from the y-axis. Make that F look a bit better. Okay, then we have our reflection that we'll deal with next, this negative that was in here. deflection in the x-axis. And then the last thing that we need to deal with is the translation, which is this 3 out the front, and it's a positive 3. That's going to shift the whole graph off, so shift is a translation. And it's going to be in the positive direction of y. And then just to show you what the graph would look like, as we worked out before, it's going to have a period of pi. It's been shifted up by 3, so I'm going to have positive 3 as my average point, my substitution for the x-axis if you like. And then the amplitude is 3, so from 3 it's going to go up to positive 6 and down to 0. We have one complete cycle within pi, and it is negative, so it's going to go something like this. That's what that graph would look like. So we had our original graph up the top here. It's been squished in, so it's a dilation factor of half from the y-axis. It has been stretched that way. The dilation factor of 3 from the x-axis. It's been reflected in the y-axis to turn in the x-axis to turn it upside down, and then it's been translated up by 3 from the x-axis, or in the positive direction of y. Okay, so that's what that graph is. Let's move on to the next question. What is the equation of the image when y equals cos x is transformed by a dilation factor of 3 from the x-axis? So a dilation factor of 3 from the x-axis is our amplitude, so that's going to mean 3 cos at the front. We have a translation of pi on 2 in the negative direction of the x-axis. So after the cos, so that bit there would be cos x, it's in the negative direction of the x-axis, so we go x plus pi on 2. And then the other bit that we have here, and 1 unit in the positive direction. It's also a translation of 1 unit in the positive direction, so it's going to be plus 1 at the end. So our equation is going to be y equals 3 cos x plus pi over 2, plus 1. And that's the answer to that one. See you next time.